Final exam study guide, page 7. So we're starting off with formulas involving compounding, and both of these questions are compounding continuously. And so we're going to use the continuous interest formula, and it's written right here. So Brad invests $2,500 into a savings account, earns 5% interest. So when I set up this formula, I need to say that my initial principal is $2,500. I'm going to use an E. I know the rate is 0.05, and I know the time is 10 years. This is strictly a calculator problem and nothing else. So I have a total, if I type this straight in, of $4,121.80. Always go to 2 decimal places for a money problem. Okay, Olivia invests $4,000 in an account, 6% interest continuously. How many years will it take to double? So I don't know the time this time. I do know where I want the goal to be. It says it wants to double, so that's going to be 8,000. So let's start the formula and put an 8,000 in the final result section, a 4,000 in the starting number section, an E because it was continuous, and a 0.06 for the interest rate. Let's leave time unknown. Alright, so this time it's probably going to require a log, and so I need to get this E isolated. So let's divide the 4,000. And then at this point, E is isolated, so I just need a natural log. Right? Natural log of 2 is going to be equal to the exponent, 0.06t. So the exponent goes across from the log, and the 2 comes in. Alright, well, natural log 2, just type it up on your calculator, divide by 0.06, you should get t equals 11.55 years. Not 54. 11.55 years. Okay, simple enough. Move on to number 51. Alright, so we're simplifying rational expressions. So that involves factoring typically. First one, I'm going to factor out a 3x. Leaves me with 4x squared minus 1. Denominator, I can take out a 6x squared. And that leaves me with 2x and plus 1. Continue factoring. 3x, 2x plus 1, 2x minus 1 from doing difference of squares. And then 6x squared times 2x plus 1. Let's cross out these 2x plus 1s. And then 3 and 6 can be 1 and 2. So when I rewrite this, oh, and also I will have x over x squared, which would leave me with an extra x on the bottom. So if I cross out that x and make this x to the first. Okay, so across the top I have 2x minus 1. And across the bottom I have this 2, this extra x. And that cannot be simplified. Whoa, wait a minute. Yes, that is correct. Okay, and that cannot be simplified any further. And so that's where I am. All right, and then I just have to remember that denominators cannot equal 0 here. So I have to do my excluded values. X can't be 0 for the first part, for the GCF part, and negative 1/2 for the second part. Okay, moving on. Number 52, we have options. We can go across the top, across the bottom if we want to. I think I'm just going to do a little reducing first though. Let's do a 6 and a 2 and make it 3 and 1. 10 and 18 can both reduce by 2, so that would be 5 and 9. And then I could go one more time with 3 and 9 and make them 1 and 3. Okay, alternatively I could do 6 times 10 is 60, 2 times 18 is 36. That's fine too. Alright, consolidating my numerators. I have a 5. I have x squared y cubed is x fifth. Y cubed and y fourth is y seventh. Denominator is now 3. And it's x squared. y2 is y4. So the x's are 3 on top, the y's are 3 on top, so I have 5x cubed, y cubed over 3. And back in the original problem, I had an x in the denominator, so that can't be 0, and I had a y in the denominator, so that can't be 0. Okay, and 53 is a keep change flip, so we'll keep the first fraction and factor as we rewrite it. We'll flip to multiplication. We'll change to multiplication. We'll flip the second fraction. So as I write this, I want to take my denominator and write it on top, but I'm going to factor it as I go. Take my numerator, write it on the bottom, and factor that as I go. And then look for some canceling. So x plus 3 can go, x minus 2 can go, and I have 10 over 8x. 10 and 8 reduced by 2, so it's 5 over 4x. All right, so then denominator factors. I had x minus 2, so x cannot equal 2. I have 0 here for the GCF. X plus 3 is negative 3. And then because of the flip, I do need to check this numerator too, because that was once on the denominator, but both of those have already been accounted for. So that's good. All right, going down to the bottom row here. So I have addition now, right? So I have to check the denominators and make sure that they're the same, and they are. So we can consolidate this into a single fraction. And the numerator would be x squared plus 10x plus 21. If this were a minus, I'd have to make sure that I subtract both parts of the binomial, but it was a plus, so I could just go right across. Now we'll do some factoring to see if anything cancels. 7 and 3 should give me 21. And this is a difference of squares, so x plus 3, x minus 3, and I do in fact have canceling to do. Take out the plus 3's, and I have x plus 7 over x minus 3. And then denominator factors, so I cannot use negative 3 or positive 3. All right, 55. So looking for a common denominator, but I don't have one yet. I'm going to factor this one to see what I have. It looks like my common denominator needs an x minus 2 because they both have that, and then it also needs an additional 5. So that first fraction is going to stay untouched. And in order to make the second fraction match the first one, I have to bring a 5 into it, which means the original numerator has to be multiplied by 5. So 20 is a result of doing 4 times 5. Do not reduce here, otherwise we'll be back to the start. We're going to go straight across. X squared plus 16 minus 20 gives me x squared minus 4. Factor the numerator. And cancel common factors. So I have x plus 2 over 5. Okay, denominator factors, the only one that had a variable in it was the x minus 2, so x cannot equal 2. Okay, and we have a complex fraction in number 56. So in this numerator, the LCM for the denominators would be x squared y squared. And in the denominator, the LCM for those denominators will be xy. All right, so going through the numerator, I want to make those both x squared y squared. And I'm just doing the top half here. So first fraction I brought in a y squared, so I need a y squared on top. Second fraction I brought in an x squared, I need an x squared on top. Again, do not reduce these or you get right back to where you started. Big fraction bar in the middle. Second one, I need xy as my common denominator. So 1 over y brought in an x, so I need to bring an x on top. 1 over x brought in a y, so I need a y on top. All right, let's push these together. So the big numerator here will be y squared minus x squared over x squared y squared. And the denominator will be x plus y over xy. So now I need to do keep change flip. as I keep the first fraction, I'm also going to factor it. Y plus x, y minus x. So that, just so we're clear, is this. Okay? And the rest of the keep step would be over x squared, y squared. Now I'm going to change to multiplication. This fraction on the bottom is going to flip over. Okay, it looks like nothing cancels, but it does because y plus x and x plus y are the same thing. Addition is fine. There's no need to reverse it. And the xy and the x squared, y squared, the x and the y are going to cancel with 1 each of these. Okay, so that leaves me with a final result of y minus x over xy. And what do I need to exclude? Well, let's see. Denominators, right? Denominators. I can't let x equal 0. I can't let y equal 0. I flipped it. The xy was on the bottom, but I already can't let those equal 0. And then x plus y, well, if I set that equal to 0, that means that x cannot equal negative y, right? Because if x equaled negative y, this would add up to 0. Okay, so that's page 7. Page 8, we're doing some graphing. Pretty easy graphing, I think. What we're looking for is a reciprocal function graph. Reciprocal function graphs, you'll recall, have asymptotes, and the asymptotes are based on the shifting. This graph shifts 3 to the left. Oh, let's write it how we normally do. So left 3. And there's no number at the end of the fraction, so it's not moving up or down at all. So our asymptotes will default to 0 and 0, but the one is moving left 3. So the other one can stay at 0. Those are my recalibrated quadrants. So I would have them going right through 0, 0, but this time it's been shifted, right? And because there's no stretch factor, I can just move 1 unit in each direction diagonally from the intersection point, and then I can connect these like this. All right. Don't need to get any more specific with your graph than that. That's good enough. Do you want to point out if this was a positive 3, for example, or a positive 4, whatever number this is, you have to count from the center, from the intersection point, that many units to the right and up, and get 2 separate points that you're connecting. It is not going to be just 1 point away from the origin. Okay, number 58, this one is moving right 2, and it's moving down 4. So I do need to make 2 shifted asymptotes. One goes to the right 2, one goes down 4. That's my new origin point. So stretch factor is 1, so I'm 1 unit away. And I can just make my curves. And remember, if this was a negative 1, I would just switch the quadrants. That's all that would happen, is I'd go upper left and lower right. Okay, solving equations, I have 2 ways. If I have a single fraction equals a single fraction, I'm going to want to do a cross product. So I'll do a yellow product and a blue product. And the yellow product gives me 4 times x minus 6. And the blue product gives me 7x, and I don't want to make a new fraction, just want to set them equal. So 4x minus 24, subtract the 4x over, and divide by 3. Double check, make sure you don't have a 0 in your denominator, and we're good there. All right, let's do the same thing over here. We're going to go one direction, x times x plus 5. Go the other direction, 3 times x plus 8. Multiply it out. Bring everything to one side because I have an x squared. So subtract 3x, I get 2x. Subtract 24. And now we can factor this. quick solving chart would give me -6 and 4. And if you go back to the original problem, neither one of those creates division by 0. So that's it. All right, a couple more. These do not have single fractions, so we are going to pick an LCM to multiply by. Looking across the denominator, I definitely need an x for those two, and I also need a 2, so we'll use 2x. And then we multiply 2x times 3 over x. This is 6x over x, which is 6. And that 6 then replaces the first fraction. Next one is again, LCM times second part. So that's 2x over 2. So the second fraction gets replaced with minus x. And the third time, 2x over 1 times 12 over x. 24x over x, which is 24. Feel free to skip all of this. If you can just see it mentally, do it mentally. Subtract 24 and divide by -1. And this number does not create division by 0, so we're good with that. Okay, same concept here. We need to do an LCM. 3x, x, 2x squared. So they all contain an x, but I need at least x squared in order to deal with the last fraction. 3 and 2, not the same coefficient, so let's use 6 to be able to get to both of them. Okay, so when I multiply 6x squared by 4 over 3x, that's 24x squared over 3x, which is 8x. So this first one becomes 8x. 6x squared over 1 times 1 over x. 6x squared over x, which is 6x. And then x plus 2, nope, let's keep it consistent. Let's do 6x squared over 1 times x plus 2 over 2x squared. 6x squared times x plus 2 over 2x squared. X squareds cancel, 6 and 2 is 3, so 3 times x plus 2. So what do we have? 8x minus 6x is 2x. Distribute here 3x plus 6. Subtract the 3. And divide the -1. And when I go back to the beginning, neither one of those, or -6 does not create division by 0. So we're good. Okay, that'll do it for page 8.